Greetings viewers, Eric the Car Guy here, and I just got me a new welder, but I have no idea how to use it. So I have come to visit Wyatt Swain, who is also known as Mr. TIG, and he's going to show the ins and outs of how to use my new welder. Wyatt, how are you?
Great to meet you, Eric.
Thanks for being on the show.
Well, thank you. Thanks for having me.
So I've got this new welder, and it's a TIG welder, and first of all, why a TIG welder? Why would that be cool?
Well, actually, a TIG welder is so versatile. You can do basically all materials that are weldable, and that means everything from aluminum to magnesium, stainless steel, Inconel, titanium, and you can weld very thin materials, and that becomes critical when you start getting into the automotive field.
Yeah, especially when I'm working on my exhaust or something like that, because honestly, that's probably one of the main places I might use this.
Yeah, well, actually, this machine will go down to real thin materials such as 16. You can get down to 18 gauge with no problem at all, and that's what you see on a car a lot.
Well, that's awesome. So, can you show me basically how to use this machine? Because honestly, I have no idea.
I will. I'll go through all the functions of the machine, and then we'll actually do a live arc, and I'll teach you the techniques associated with TIG welding.
So why AC/DC? Why is that important about this?
Okay, well, this particular machine, as I read through the manual, and this is the first time that I've actually ever looked at this machine, haven't even welded with it yet. So the machine has an AC function that will allow you to do aluminum and magnesium, and that creates a cleaning action because there's oxides on aluminum that are just difficult to get off. So if you try doing it DC, it just would be ugly.
So I guess that's one of the important things about the weld, to be clean.
It is, but I can tell you today's machines typically do a great job cleaning as long as you wipe it down. I mean, you can go to a very fine degree of grinding and polishing, but basically get off the oxide, just surface oxides, and then you can wipe it down with acetone.
Okay. Well, it sounds like you know a lot more than me, because normally when I've welded in the past, I've just sort of pointed and shot and, okay, it's together. Done.
All right. Well, fit up is good, and like I say, TIG welding is a little more difficult than MIG or gas welding. But we'll show you, once you get the fundamentals down, you won't go back to any of the other processes.
Well, that's good. But I am looking forward to it, because I am excited to have my new welder, and looking forward to joining things together.
Well, good. So we'll get started in the setup. Well, Eric, I want to start off with this button right here, or this knob, and you can turn it low or you can turn it high. This is your amperage control, probably the most critical feature on the machine. Now, you're probably wondering, why do I set it high, why do I set it low? Well, first of all, you need to know that the rule of thumb is take a look at the thickness of material that you're welding, and you want to set your machine for approximately 1 amp per thousandth of thickness. So 16 gauge, you're going to set the machine at probably 60 to 65 amps.
So how am I going to know that? How am I going to know, like, how thick? Do I actually measure the material, or am I just going to guess in my mind?
It really is just a guess. And all you're trying to do is you're just trying to give the machine a little bit better control. Now, if you're a little bit under amperage setting, it's going to take you a little longer to start the puddle. If you're over amperage, you're going to get a puddle immediately, and you're going to have a very high travel speed. So you're trying to find that happy medium somewhere.
So pretty much it's a guess to start with.
It is.
And the amount of amperage pretty much equates to the amount of the puddle, like you said, that I'm going to get when I do the weld?
It is. And an example, let's say you set the machine on 10 amps and you strike an arc. You're just never going to puddle up. For 16 gauge. You will probably in about 20 minutes, but that's not what you're looking for.
So if it's taking a long time, I need to increase the amperage, is basically what you're saying.
You do.
So for the thicker materials, I'm going to be using a higher amperage, and for the thinner materials, I'm going to be using a lower amperage.
Correct.
That basically?
Yeah. And this machine, according to the instruction manual, will give you 5 amps up to 185 amps. So again, use that. You can do some super thin materials.
Hence the reason why it's a 185.
It's a 185, yes.
I get it now.
Yeah.
Awesome.
Yeah. So let me turn the machine on and just show you the function of amperage.
Cool.
Okay, now I've got this machine plugged into 110. This is a dual voltage. You can run it off of 110 or 220. If you run it off of 110, it's only going to give you so much output. So let's see.
So if I wanted more?
Yeah.
Okay, so it's only going up to 124 right now?
Yeah, so you're only going to get 124 amps out of it.
Okay, but if I switch to 220, I could go up to the full 185?
That's correct.
Okay.
That's correct. Most of the time, my welding applications rarely go above 124 amps.
Okay.
So you'll see the challenge more when you're welding aluminum.
So rather than unplugging the dryer in my house so that I could run this thing, I could just plug this into 110 and be happy?
That's correct.
Awesome.
Go ahead and turn that knob just so you get a feel for it. Okay, so that's some pretty low amperage. Let's go ahead and set it somewhere around 60 to 65. Okay, now that's going to do most of your 16 gauge material.
Okay, so most of the time I'll be in that zone.
Yes. Yes. Okay, I'm going to go ahead and shut the machine off. And I want to go through the functions that you see here. This is actually a pretty simple to use machine.
Good.
This button right here, if you do a close up on that, you can see that it's got AC and DC on it. So if I put it on AC, I can do my aluminum and magnesium.
Okay.
Now,
and that would be the only time I'd really want to use AC?
Yes, correct.
Okay.
Now you can do cast aluminum as well, just a dirtier material.
And is that the same as, okay, so AC alternating current and DC direct current?
That's
The
correct.
difference between the two?
That is correct.
Okay.
Okay, so if I want to go on DC, if I want to do 4130 chromoly, steel, Inconel, titanium.
If I'm building a tube frame for my race car.
Yes, you'll be on DC. Okay, and that would be DC negative. Okay, so once we finish with this knob, we move over here. Now this gives you two different functions. If you're on this function right here where it says panel, I have a torch where you can push a button and whatever you see on the panel is what you're going to get.
So whatever amperage I'm seeing here?
Yes.
Is the amperage I'm going to get?
Correct.
Okay.
Okay, now if I put a variable foot control, when I say a variable, it says pedal. Then you have to put the pedal option on. Now, the pedal option gives you a variable control very much like driving a car, 0 to 120 miles an hour.
So it's like a gas pedal, so to speak.
Absolutely.
And that can vary my amperage instead of me turning this knob?
On the fly, yes.
On the fly, so I could be sitting there with the gas pedal and I could say to myself, well, I'm not quite getting the puddle that I should have, and I could step on the gas and it will increase the amperage and I'll have that just right there on the fly?
Yes.
That's awesome.
Okay, now we're going to get into these green buttons here. These happen to deal with only AC. So unless you're on the AC function welding aluminum, they mean nothing. But what you're going to find is on these machines, it'll say AC frequency. Now, the frequency coming out of the wall is 60 hertz. This machine actually can change the hertz, and you can go to a higher hertz. This particular machine says it can go up to 250 hertz. Now, what does that do for you?
Yeah.
Well, the
What does that do for me?
the actual arc changes. It goes from a soft arc to a very tight arc. So if you're trying to get into a fillet weld or a tight spot, turn the frequency up.
So if I'm going into very small areas, I want a higher frequency to narrow that beam, so to speak.
It's
Is it
like
okay to call it that?
Well, it's an arc, and it has an arc cone to it. So that arc cone tightens up. Now,
and that's only on when I'm on AC.
Correct.
There's no need to worry about that when I'm on DC.
That's correct.
Okay.
It's the function is actually out of there. Now you can turn this all the way over to, I think it says 20 hertz. Now that's a very soft arc. If you're doing a build-up, let's say that you have an engine case or something aluminum that you knock the ear off of.
And you want to build that up to grind it back down again?
Yeah, not that ever happens.
No. We never break things.
Yeah.
We always fix things.
But if you want to build that up, put it on the soft arc.
Okay,
so it'd be at 20. And if you don't know, just set it straight up and down. And
just to start with, and then you can make the adjustments accordingly.
Absolutely.
Okay.
Now let's go over here to what's called AC balance. Now over the years, we used to have to clean aluminum dramatically. We used to have to scrape it, file it, do all kinds of things. But we now have what's called a balance control, and the AC actually has a portion of that AC that cleans the aluminum oxide. So you have to determine.
Tiny little people that jump out and scrub it up for me?
Yeah, pretty much electronically.
Okay.
But if you're welding aluminum, start with the balance straight up and down. Now, as you turn to the left, you're going to find that the setting on here says
negative.
It's got negative. As you go negative, you get deeper penetration. As you go positive, you get more cleaning and less penetration.
Okay.
So there's a balance there. Look at your material. If it's really, really dirty, you need a lot of cleaning. If it's not terribly dirty, you don't.
So cleaning, I want a higher percentage, or more penetration, I want a lower percentage.
Correct.
Okay.
And really, from a functional standpoint, that's all there is to this machine. Now, in the setup of the machine, I want you to look right here, and this is a little DINS 25 connector.
Okay.
And that's your ground. Make sure you hook your ground up.
That's the clamp that I'd clamp to complete the arc, so to speak. Because basically what I'm doing is I'm welding with electricity.
Yes.
I'm passing current through a material which is leaving behind the weld.
Yes.
Is that correct?
That is correct.
And then so you need an in and an out as far as electricity goes. So
absolutely.
you say that this is the ground, but yet it says plus up there. So why is that?
Well, we're actually setting the DC and AC up here.
Okay.
Okay, so we're going to put the ground on this unit right here.
Okay.
And we're going to put the TIG torch on this side right here.
That just seems counterintuitive to me. That's the only reason I'm somewhat confused by that.
Because we're primarily going to use this for TIG welding.
Okay.
You can also use this for stick welding.
Okay.
And so you can change the leads accordingly.
So in other words, I could change the leads on this and stick weld?
Yes.
Is what you're saying?
Absolutely.
It's a pretty versatile machine we have here.
It is.
Okay.
Okay, now this little device right here that's your argon gas.
Okay.
And we hook the torch in.
And that argon gas is there, why?
Anytime you're running a liquid puddle on metals, you need to have shielding. And the shielding needs to be something that's inert. Argon is very inert, very low in cost. So you can use argon for any material in your shielding.
So that gas goes in there and pushes the oxygen out of the way? Is that what I'm trying to do?
It does. It displaces it.
Okay. So basically there's argon around the outside, so I won't have that oxidation, so therefore I'll have a cleaner weld?
Absolutely, yes.
Okay. I get it.
There should be no slag whatsoever. This control right here is either for the torch that comes with the machine, or you can put a foot pedal.
Okay, that foot pedal, the gas pedal we talked about earlier.
Yes.
Just going for the car analogy.
There you go.
It's the car guy thing. Okay, so the argon gas. I got the welder, but it didn't come with the gas. And once I get the gas, how do I set the gas up on the tank to work with this welder?
You can find a gas distributor that sells these bottles or leases these bottles. Just go to your yellow pages, and they're readily available. Now, this particular regulator that you have has some readings on it. Now, the liters per minute is not normal to the United States, so you have to kind of convert it. What we're looking for is CFH, cubic feet per hour.
Okay.
So typically the torch setup that you have is going to be right around 15 CFH or cubic feet per hour. You can convert that and take liters per minute in about half. So somewhere between 7 and 8 liters per minute.
Okay.
And other than that, you set that at 15 CFH, and you're pretty good for just about every application.
So the only real number I need to remember is 15 CFH to start with, and that should get me where I need to be?
Yes.
Okay. Well, that's a nice tool you got there, Wyatt.
Well, thanks. This is a TIG torch, and this really is critical to your application.
That's the business end of what all that stuff over there is about, isn't it?
It is. It is. So what I want to describe to you is what we have in here is tungsten. And I like to use, for any inverter machine, I like to use a 2% thoriated tungsten. Now this is 1/16 in diameter. Now you can go smaller or larger, but this will handle up to about 90 amps.
Okay.
And when welding DC, we want to grind it to a point.
So if I'm up higher than 90 amps on that, I need to get a different tip there?
You do. You need to go to the higher size, which is 332 tungsten. Okay. And then that tungsten will withstand up to about 185 amps.
Okay. So how do I know I don't have the right tip, or do I just go by the amperage on the front of the machine?
I just, first of all, you have to know that this tungsten will only handle 90 amps.
Okay.
And there's a lot of literature. You can go to weld.com. There's a lot of literature on tungsten.
Oh, that's an excellent resource.
And it's got the capacity of tungsten. So again, 1/16 will handle just about everything that you need on a car.
Okay.
If you're at the high end of the machine, go ahead and change it to 332. But I've got this with a pointed tungsten, and the stick out is about 1/4 inch.
Okay.
That's just a nominal start.
Okay. And then you tighten it down when you...
I tighten the back cap, and there's a collet inside that tightens it.
So I've got a 1/4 inch coming out. and then I tighten it down with, what would you call that?
This is called the back cap.
Okay, with the back cap. All right.
Okay, so when you get started TIG welding, one of the things you need to know is how to hold the torch. Now this particular torch it's a pretty large torch. It's designed for not having a foot pedal, and you have a switch right here. Okay, so when you hit this, it activates the argon, and an arc will come out, initiate the arc.
So that's just like the on-off switch, unlike the pedal where I can vary things with the pedal. Once you do that, whatever it's set for on the machine, that's what you get.
That's it. Okay. And it's actually easier to get started that way, just to learn the functions of holding the torch angle. Mm-hmm. Okay, so now that you've got a torch in hand, are you right-handed or left-handed?
Mostly right-handed.
Okay. We won't hold that against you.
I will.
Okay. Make your torch hand your dominant hand, and you can hold this very much like a pencil. Mm-hmm. And you're going to be using your index finger to touch that button, and you've got a live arc, and you get this tungsten as close as you can to where you're going to weld.
But you don't want to touch it?
But you don't want to touch it. Once you touch it, you've contaminated the tungsten, and you've got to regrind it.
Oh, wow.
So that's the challenge.
You really don't want to touch it?
No, so you could practice doing dry runs.
Okay.
You could practice. Now, I'm not going to go live, but you could practice just like drawing a line with a pencil, getting close.
What would be the optimal distance?
About the distance of a penny.
That's a good number.
Yeah. So if you could slide a penny under there and keep that steady all the way. Now the guys that have problems welding in the beginning is they raise it and lower it, raise it and lower it.
Right.
Okay. So all we're trying to do is get it very, very close.
What if I did something like this? If I just took like one hand and laid it down like that, could I just do that?
You could do that as long as you're fusing the weld. When I say fuse it, it's an autogenous weld. If you can take two parts and melt them together, mm-hmm. you can do it with one hand. But eventually, you're going to have to add filler material.
Okay.
The reason for that is because you're going to have gaps. You're going to have to fill it.
So what is that, a really thin coat hanger?
It's very much like a coat hanger, yeah. A little more precise than that. But so, and I'm going to show you the left-handed technique. Right. First of all, you need to know that the torch angle is very critical. When you're welding, you try to keep your torch angle almost straight up and down.
Okay.
Now,
does that help with that argon gas distribution on stuff also?
It does. Your puddle is symmetrical. The argon distribution is very good. And the more you tilt, the more difficult the weld gets.
Okay.
Now, this is okay, 15 to 30 degrees.
But in some ways that makes it harder to see. So when I'm doing something like this, I want to get my head down there so that I can see.
You can actually do both. You can get your head down, tilt it a little bit, tilt the torch a little bit so you can see the puddle.
Yeah, because welding to me has always seemed like a little bit of alchemy in this regard, to where it seems like almost the people that I've seen that are really good at welding almost aren't really looking at what they're doing. It's almost like they're using the force or something to figure out where to weld.
Well, in TIG welding, you've really got to focus in. So eyesight is critical.
Okay.
And we're going to go into the segment in part 2 where eyesight becomes really critical, especially after you turn 40.
I'm past that.
Okay, so we have a puddle here, and throughout the day, you're going to get tired. When you turn the torch angle that much, then it's going to start wandering on you.
Okay, so our takeaway is try to keep the torch perpendicular to the surface that you're
as much as you can. Again, the only reason we angle is so we can see.
Okay.
Okay, so the angle
so is least amount of angle so that you can still see what you're doing.
Yeah, so that's the direction that I go.
So it's not that I'm using the force, I'm actually looking at what I'm doing.
You are, yes. Okay. The second part of this is once we get a puddle, then we're going to teach you how to add rod to the base of the puddle. So it's a dabbing technique.
Okay. So there's nothing that comes out of the torch itself that's doing the welding. It's this filler material that's actually doing the welding?
Well, the arc itself is creating the puddle.
Okay, so that's actually joining the two metals together.
Yes.
On a molecular level, so to speak.
It is, yes.
Hence the weld. Okay.
Okay, so we're going to go into phase 2, but before we do that, you need to know the safety features of TIG welding because it does create a little bit of radiation, not as much as some of the other welding processes, but we still have to use a welding helmet.
Okay.
Yeah, so I want to identify a couple of
radiation,
things.
What do you mean, like ultraviolet radiation?
Ultraviolet's very, very much like a sunburn.
I was just going to ask you, should I be wearing SPF whatever when I do this?
Well, you need SPF 75, I think, on this.
Seriously?
No, you need to wear sleeves, and we're gonna put you in sleeves that's going to cover up your arms here.
Stylish.
And then we've got gloves.
Can I just wear one glove? Could I be the Michael Jackson of welders?
Well, you can, but one hand is going to be sunburned, so
we don't want to expose just the one hand.
I happen to have a welding helmet here, and the welding helmets today allow you to weld very light amperage and very heavy amperage just by turning a knob.
That's wicked cool.
Okay, so what we have here is a helmet that is set at 9 as far as a shade, and most of our welding is going to be at about a 10. Okay, so you can adjust it on the fly.
So I can adjust that on the fly while I'm there if it's too much or not enough? Or...
Yeah, so I'm going to let you use this helmet first, and then I'm going to use this helmet, which amazingly has a cheater in it.
Oh, cool.
Okay, now...
so is that like little magnifying glasses?
It is.
So seeing that weld would be even easier with those?
It is. Yeah.
I like that.
Yeah, when I first started welding, I didn't wear glasses at all, and I wear reading glasses now. That takes the place of reading glasses.
I might just have to try that out.
So there's a place in the helmet to slide it, and
voila, you're magnified and protected from UV-ness.
Yep.
Wyatt, thank you very much for showing me how to set up the machine. In the next video, we're going to actually cover some live welding, but I think it's really important to know what I have there and how to use it and how to twiddle all those knobs just right, that kind of thing. But it's absolute pleasure. Thank you very much.
My pleasure.
I am Eric the Car Guy. You can always find me at ericthecarguy.com or on Google, Facebook, and Google Plus, Facebook, and Twitter. Yeah, you almost got me there, didn't you? And you can find Wyatt at weld.com, and I'll post a link in the description to that if you have questions on welding or any of those types of things. Anyway, be safe, have fun, stay dirty. See you next time.
Now, just so you know, the argon that's in here,
the argon that's in here is poison.
Yeah, it's got arsenic in it.
This is your last shoot, Eric the Car Guy.
Okay. Okay.
Thanks for coming. Good night. Lights out. All right, we can.